Good evening. Shall we start? We have seen basically three data types. That is what we call them is primitive data types. So integer, character, and real. Because we know that all other data types like pointer, array, string, structures, union, type def, all these are secondary data types and these are derived from the primary data types. So these are primary, primitive, built-in. Anybody can use. Let's have a quick review what we learned in the first chapter. So there is the integer data type and keyword is int. Usually nowadays 4 bytes of memory is allocated for the integer variable and its range is -214748 36482 plus 214748 3647. Right? So that is the minimum number it can store and maximum number it can store. That we call it is a range. There is one more data type that is short. Okay, it takes 2 bytes of memory. Usually application developers do not use this, but compiler developers yes. Those who write compilers for C language or C++ language or even interpreter of Python, they have used the short keyword, right? So short is an integer data type. It takes 2 bytes of memory. So obviously for 2 bytes range is -32768 plus 2 plus 32767. There are modifiers we have seen. Two modifiers are there. So signed and unsigned. These are not data types, but these we call it as a modifier. So obviously there would be 4 combinations. So there will be signed int, and signed short and unsigned short, right? So this we have already covered. Then there is a character data type rather, right? Keyword is char. If you go to, or some of you go to US or in European countries, rather basically US and Australia, they do not pronounce this as a char, but they pronounce it as a char. Okay? You should know that. So 1 byte of memory is allocated and range is -128 to +127. We know that. Obviously, there are modifiers like signed char and unsigned char, right? So when it is unsigned char, then obviously range will be 0 to 255. Signed is the default modifier, so that's why we do not use as a signed int. We do not use that because it is the default. When you use the signed int x, it is as good as signed int x, and it means it can take negative values as well as positive values. Same applies to character. The third data type is the real constant, and it is there are 3 variants of real constant. So the float 4 bytes of memory. So range is -3.4 e raised to 38. I have told you that e stands for e raised to 38. That is 10 raised to 38. That is how you can store large numbers. So -3.4, 10 raised to 38, 2 plus 3.4 e raised to 38. That is 10 raised to 38. When you declare variable as a double, I have told you double is the intrinsic data type of a real constant. That is the intrinsic nature of a real constant as far as C language is concerned, or even C++, Java, everywhere. So when you declare any variable float x is equal to 5.4, On the right hand side, actually 5.4 is a double, not float. That is the reason I have always told you that when you initialize any float variable, then attach the letter F in front of that float constant or floating point constant. So double takes 8 bytes of memory and range is huge again, minus 1.7 e raised to 38 to plus 1.7 e raised to 38, 308, not 38, 308, 10 raised to 308, huge number. There is a long double, it takes 10 bytes of memory. The range is, I mean, uh, very difficult to imagine as well. Minus 1.7 e raised to 4932 to plus 1.7 e raised to 4932. After all these values are architect dependent. So if uh, machine changes, it's a 32-bit processor, 64-bit processor, or a 128, again the values will be bigger. Now, this is important. So, what is basically this title may be new to you. You might not have heard it before. Whether a variable can have dimensions. So yes, variable in C has got dimensions. It has got two dimensions. One is the time dimension, another is the scope dimension. Right? Two dimensions are there. So what is time dimension after all? Time dimension is for how much time that variable exists. That is the time dimension. What do you mean by exist? It means it is alive, right? It is alive. Because during program execution, variable, what you can say, variable is created, memory is allocated, variable is destroyed, memory is deallocated. That process goes on always, right? Always. And that too during program execution. That time dimension relates along with that. So how much time a particular variable is alive, that is very important for programmer, because we declare variables to get the work done. So we should be aware about the time dimension of that variable, right? And another dimension is the scope dimension. What do you mean by scope? Scope is the region in a program in which that variable is visible. That is the scope dimension. Okay, so there is a program in what region that variable is visible. That is the scope dimension. Right? When I write program, I will explain all these things in detail. Let me cover points and then I will directly we'll go to the program, and all these what I have told you. Okay, actually theoretical concepts of all these concepts. I mean all these terms. I mean explaining you. Part of that you may not understand since it is a theoretical, but obviously theory helps for concrete understanding, right? Only programming, writing program doesn't help, right? Like uh, for as far as quiz is concerned, okay, that is a theoretical quiz, right? There is no computer in front of you. Some questions are there, and even though you are a very good programmer, even though you can write fantastic codes, it may happen that you know cannot answer that. So intention of quiz is that, okay, to make your foundation strong, right, and concrete, right? So that is dimensions of the variable. Then there are categories of variables. So what are the categories? Categories are two categories are there. One is a local variable and another is the global variable. What do you mean by local variable? The variable declared inside a function, we call it as a local variable. And variable declared outside function, we call it as a global variable. Right? It is basically a global variable, rather provision of a global variable. I will not say a global variable. Provision of a global variable by Dennis Ritchie. C language uh, is criticized, okay, by many programmers in this world. Criticism is always there, right? And the more popular you are, more criticism is there. So C is criticized always because of this global variable provision. But Dennis Ritchie has not forced you to. He has just provided you the facility. But it doesn't mean that you are forced to use it. No. But we should know that how to, what is the role of the global variable, how does it work, and no, what are the pros and cons of that global variable. That is also very important because world was there before C++, right? Before Java, before Python, world was there. Computers were there. Even all major operating systems were written before all these modern languages, right? So if all these operating systems and were written, definitely uh, uh, those concepts in C programming language were sound, right? So one cannot, you uh, deny the fact, and one should not criticize only without knowledge. Then these are the subcategories as far as local variable is concerned. So there is an auto, there is a static, there is a register. All three are keywords you can see. So auto is the keyword, static and register. Auto stands for automatic. Hmm. Interesting part is there as far as all three are concerned. And auto is the default category. So whenever you declare a variable as index, not just signed is the default, but auto is the also keyword, default. And since it is the default, we do not use that auto. So what are the parameters of this all auto, static, and register? On the left hand side, a popular diagram right from day one. I have been showing this. Right? I call it actually basically data segment. It is a pictorial representation. So there is a stack. Okay, in some books you may find it in reverse order. So you'll find stack at the bottom, afterwards heap. There is a static like that. Okay, but after all, it is I mean, everywhere it is a pictorial representation, right? Because world itself is a full of reference, right? India is at west for some countries, and India is at south. India is at east for some countries, right? So it is a reference. auto. What is the initial value? Initial value, auto variables. Initial value is garbage, right? I have seen that some compilers zero is given, but that is not reliable. Okay. So basic is that auto variables are not initialized to zero. If you have not initialized them, it contains garbage or a junk. We call it as a junk value, garbage value, or even undefined value. We cannot define that. Okay. We cannot imagine what it would contain. Now, what is the scope of that auto variable? Scope of a auto variable is the region in which it is declared. So if you are declared variable inside a function, then I told you what is the scope, the region in which the variable is visible. So scope of a auto variable is if you are declared inside a function, then that in that full function, that variable is visible. But when I say scope, scope is defined by what? I know you have forgotten that. Scope is defined by, anybody can answer me? Riju, Suma, Dipti. How scope is defined? I have told this, I have said this. I want to check how carefully you listen to my sessions. How carefully. So can anybody tell me? Anyone? Anyone? Fast, quick. If you say, if you know, just tell. If you don't know, say no. So we don't know, sir. We have forgotten. Whatever. But at least answer something. Let me know you are live or not. Yes, Riju, are you there? Okay, Riju forgot. No problem. An association of a name to an entity. No. Dipti may no. Probably you heard not. Dipti, perhaps you couldn't understand the question. There are others. Suma, Anshita. See, I will tell you, students. I will tell you, my friends. You watch millions of videos on the internet, on the YouTube. I bet you won't get this knowledge, whatever I have taught you in 1.5 months. You won't get all this at a single place. I'm quite sure. Quite sure. Take any course from Coursera, wherever you MIT, okay, edX, all these are big portals, big giants. No, it is not lifetime. Okay. I told you, friends, scope is defined by curly braces. That is the curly brace which defines the scope. That is the reason we write the curly braces after main function. What is the reason for that? We should know. I have told this. I have told. Go and watch some videos. You will find this word. That opening and curly braces. Right? So the variable can be stored. A variable, I told you, variable is declared and When I told you the sentence, I can recall, I can remember. Uh, Variables in C are declared at the beginning of the block. I told you. And how block is defined, how scope is defined by curly braces. Right? That is the block. That is the scope. So that that visibility is limited to that block or a scope. If you are declared at the function scope, the variable is visible to that function. If you have written some loop, suppose, and inside loop you have declared variable, have you declared in the past? No, you have not declared in the past. I intentionally didn't declare, right? I wanted to see whether you have written some codes using that, but nobody has tried that. You can declare variable inside of loop as well, right? So obviously, when you declare a variable inside loop, then scope is limited to that block. If you declare a variable inside if block or else block, these are a block. I am using the word block, right? Block is a scope. So scope is limited. Visibility is limited to that opening and curly brace, right? Okay. So that is the scope of a auto variable. What is the life? Life is for how much time the variable uh, is alive. The variable is alive till the control goes outside the, what I can say, outside the closing brace. That again, scope is defined by closing curly brace, and when control goes outside that closing curly brace, variable is destroyed. Now, don't get confused between scope and lifetime. No, scope is different. I have given you definition. Scope is the region in which that variable is visible. And life, the variable exists, the memory is there. Okay, it is not destroyed. That is the time for which the variable exists. So as far as life of auto variable is concerned, the variable is destroyed, memory is allocated as soon as control goes outside the closing curly brace. Very important. And where is the storage? Where all auto variables are stored. So all auto variables are stored on the topmost portion of the diagram in front of you. That is the stack, right? All variables you have declared till date, all have take position in the stack segment, stack part of data segment, stack portion of data segment. All variables. You declare array, you declare structure, you declare string, you declare a lot of things, right? All variables they occupy space on the stack, right? So you can imagine, right? Stack is the smaller, you can say smallest portion of that huge data segment, right? And marginally you are using that, or rather you have used that. And stack is a flexible, right? Size of the stack, or rather the stack is not flexible. Yeah, stack is a flexible, so it increases its size. Okay? Some fix is given right at the beginning, but that changes, right? So that is an interesting mechanism, obviously, right? So there is another um, uh, local storage, what we call is the register. That is the keyword. So you can declare variable as register int I. You can declare that. So what is the initial value? Initial value of the register variable again is garbage. Right? Scope and life same as auto variable. Right? Same. So scope, that is visible to the region in which it is declared, and life, as soon as control goes outside the closing brace, it is destroyed. Where is the change? That is the storage. Major change. You know, first of all, how statements are executed. When you write a small program, int xy, int sum is equal to x plus y, printf sum, right? Visualize that code in front of you on the editor. How it is how this program is executed inside the machine. First of all, 4 bytes of memory for each x, y, and sum are given on the on where now we can say on the stack, because we are into the storage class chapter now. That is the reason I told you that in this chapter programs won't be there, assignments won't be there, but this is we are going to implement in all throughout the C programming language while writing any program. Because when you purchase something, you go outside and purchase something. First of all, there are a lot of things we do not think like that. Okay? We go and purchase. That's it. You go to the mall. You go to the mall. You go to the this thing. What that? D-Mart and all these things. Right? If you go to the mart, if you go to the mall, and if you want to purchase 1 kg of sugar and 1 kg of rice, okay, I'm quite sure there is not a single person in this world, perhaps, who will purchase that and will come out. I'm damn sure. Right? Don't take literally. There might be some people. So they purchase this purchase this, this. While purchasing, they do not think, first of all, whether I need this. Really, really need this. Second, to store this, whether I have got a space in my home or appropriate space in my home. Right? And if you don't have that, then you will throw it anywhere you find that space. And there is a mess. Okay? Because you don't have space to store that appropriate space, right? Then you will put it somewhere, you will dump somewhere that you may not find that when you want that, when you need that. Okay, or when you want to think of that, you had purchased that 2 years back, you have not used it at all. Let's throw it. And if you want to throw it, you can't find that. Where I kept, don't know. What I mean, storage is very important in our day-to-day life. So we should know whether we have got that space, appropriate space. Why I'm telling this? When you become a programmer, you have to think from all angles. When you declare a variable, where it should take space, how much it will take, okay? What should be the storage class specifier, what should be the modifier, all these things we need to uh, think of that. That comes under the design of the program, friends. Design of the program. My all student should not become a coder in the future for lifetime. Okay? For 1 or 2 years, it is okay. But uh, your your aim should become a designer. Right? Designer is very important, and designer is a vast job. Okay? Design of a software very important. Design of a software doesn't contain a single line of code, but you think of what kind of functions are required, what kind of variables are required, what kind of storage specifier is required, right? What should be name of variables? What should be name of functions? What should be prototype of function? Okay, how the control will flow? What control structure you are in need of? What algorithm you need to implement? All these come under the design of a software, right? So very important stream of uh, IT, information technology, right? So this register is basically physical memory. This memory is a kind of logical thing. Not logical exactly, I can say it is also physical, but there is a difference. When sum is equal to x plus statement is executed, this statement is executed, it is fetched, right? Because each statement is fetched and processed, and where is processing takes place? Inside the CPU. So inside the CPU, the value of x is fetched, value of y is fetched, but it is fetched. Value is fetched means it has to be stored, right? It has to be stored. Some storage must be there. That's why I give you example of that um, mall. Okay, when you get that, you go to the market and get some huge cupboard or a washing machine or even a car. Okay, you don't have a place to store the car in your home. You dump it on the uh, public road, right? Because you don't have garage in your home. It is like that. So CPU inside CPU processing goes on. All right. So that when X is fetched, plus is fetched, addition is to be done. So X and Y are fetched and addition operator is to be done, right? So CPU has got two units. One is the arithmetic logical unit and one other is the control unit, ALU and CU, logical unit and control unit, right? So this X contents of X are fetched. It has to be stored somewhere. CPU before processing processing, that is before adding two values, those values need to be temporarily stored. And that storage, there is a registers inside CPU. Okay, those who are doing computer engineers, they might be knowing more than me. So these registers are not they're not huge in numbers. Yes, these registers are very less in numbers. Maybe 15, 20, 25, 30, like that. Okay, I haven't got to the details of that CPU design, but these are small in numbers. I know that. Now see, these are small in numbers. Okay, these the contents of that are changed regularly, right? So X and Y are fetched. So X contains 5, suppose Y contains 10. So one memory register, one register will be having 5, another register will be having 10, and that will be added. Result will be stored in some third register, and then CPU returns that value and store in the memory of some. right? Because that is memory on the stack, right? But Dennis Ritchie gave you one facility to as a register as a storage specifier. So if you declare a variable as register index, then you are requesting the compiler, do not give space for this X on the stack, but register itself. What is the benefit? Obviously, benefit is that since there is no fetching, okay, values fetch on the data segment. So obviously, time is reduced and code will be efficient, so code will be faster. So in earlier days, there was a practice to declare variables as register variables, okay, so that it's that memory is given on the register itself. Many times, no, the value of that. I have read that I have not used that. I mean, in the programming while writing academic applications, I have used that only for the teaching. But sometimes loop counters are given uh, space in the register. Right. Why? Because loop counter should be incremented and it is immediately available. No, what is that incremented? Right. So that is how. Uh, but mind you, very important. Register is a request to the compiler. So compiler may honor the request or may not honor. Okay. If a compiler doesn't honor your request, it is decided by compiler and operating system. If compiler doesn't another operating compiler, if compiler doesn't honor your request, then that variable is treated as auto variable, right? So you cannot force compiler. Compiler, no, when it compiles the program, it takes overview of that. How many variables are there? How much PCP is going to be busy, right there. Okay, and that decision is taken by the compiler. So it is just mere request. It may be honored, it may not be honored, right? So that is about the register. But one more thing. This is very interesting. One more thing. If you declare a variable, because see, depends upon this is what I am sharing information along with you. You won't find anywhere. This I have uh, basically on the basis of my experience, on the basis of interaction along with some expert C language developers or expert C language trainers over the years. I mean, over the years. So, some points I'm sharing along with you. As far as register variable is concerned, uh, it is said that if you have got if you have got suppose 10 variables, right, in the program, if you declare first variable as a register, there are greater chances that it will be given memory in the register. If you declare as the 10th variable, 10th line, there are lesser chances. This is a research paper is there, and I came across that research paper, right? And I'm sharing this along with you. So this is just I'm talking about the possibility. Second point is if you declare a variable as register and even a preprocessor dishonored, okay, your request. I mean it is uh, your request and it is treated by compiler as an auto variable, then still one of the research papers says that register variable is given priority treatment, special treatment while accessing that variable by the CPU, right? So benefit you get. Okay. So this is how register variable works, right? There is a fourth one called static, right? What is the static variable? Static is the keyword. So if you write static index, then memory is not allocated from the stack portion of the data segment, but there is a bottom portion called static and global. Okay, from there memory is allocated. Right? What is the initial value? Static variable is initialized to 0, right? Keyword, right? So initial value is 0. What is the scope? Scope is limited to the block in which it is declared, right? So that is not visible to outside that block. But static is special only because of life. Okay, life of the static variable is till the program finishes. Since it is not on the stack, it is on the separate part of separate portion of data segment. So life of the static variable is throughout the program. When program finishes, when program goes outside the main, okay, at the end. So one static variable is given, it is alive throughout the program execution. And storage, I have told you, storage is at the static or global part of this thing, right? And global variable. I told you global variables are variables which are declared outside the main function. So there are two basically. Okay. There global variable, again two modifiers are there, static and external. What is that static and external? I will explain you. It is 8 o'clock. Uh, some of the things I will teach, and next lecture we will continue. Right? This is the scope. Right? So you declare a variable, I think text is equal to 5. This is the auto variable. Right? So the auto. By default it is auto. Let's check whether it contains garbage. No, it is 0, but it is unreliable, I will say. Okay. Nowadays, many compilers print it as a this thing. Uh, what? 0. I don't know. Suppose I call some function. First write the prototype. void, suppose I write name of some function. Some function it's int, and I will call this as a some function. We'll say int x, printf x is equal to percent d slash n x. Some function int p, right? I write p is equal to 10 printf p is equal to percent d slash n, right? So what will be output? It will be 0, 10, and 0. Okay, 5. So it will be 5, 10, and 5. Right? Now, because we will discuss today only auto variable. That's it. Right? All features of that auto variable. Let's print address of x. Right? Let the percent u. Percent u is for percent u is basically for unsigned integer, and address is all address can be only unsigned, right? That's why percent u. I heard that there is a one data type, pipe type data type, uint. I have not used that. Rather, I don't remember. Once I have used that uint, unsigned int, uint is there. Check it if you can. Address of x is ampersand x, right? So see here, x is 5, address some huge number 6487580, right? P is equal to 10 and x is equal to 5. Now, if I write x, 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 and x, right like this. And if I compile the program, then what would be output? What do you say? What would be output? 5, 10, 10. Okay. Is it any other thinking? Okay. The answer will be 5, 10, and 5. The reason is that this x is local to this, right? And this x is local to this. Scope of this x is limited to this block, whereas scope of this x is limited to this block, right? So this x is visible to this much region, whereas this x is visible to this much region. So this x will be having separate memory. If I try to print that, see the difference. They are completely away from each other. 6487, 536, and 580. So they are staggered, okay, separated from each other. And that is the reason compiler is not confused, even though name of formal and actual arguments are same. Compiler won't be confused, right? Now suppose declare one variable as x int I, suppose, right? And I write for I equals I less than or equal to 5 I plus plus, right? And where it is a void, I write this as a x plus plus. So what would be out of this output of this code now? No, how many outputs would be there first of all? Okay, I will simplify this. I will remove this address now. That's it. Right? So what would be the output? Five address of 5, then 10, 11. Okay. The output will be 5 and 10, 5 times and 5. What is the reason? The reason is that this is an auto variable. So what I told you, life of that variable is still the control remains within this function. So no doubt, when first time control goes inside this function, 10 is assigned to x and x becomes 11 here. Okay, here x becomes 11. But when control leaves this function, right, the variable x is destroyed completely. Memory is given back to the operating system. Again, when control goes, again memory is allocated, again 10 is stored, and it will again this thing, right? So I think you have understood the difference between scope of a variable and life of a variable. When I say scope, what do you mean by scope? I mean this. This is scope. Okay. This program will give an error. Why? Because what does it say? P is undeclared. Okay, you cannot say you have declared that. Why? Because you need to recall the scope of a variable. Now, this scope of this variable is limited to this function. That's why uh, this is not the region. Okay, this variable is visible only to this region, not this. This is the other region, completely other region, right? That's why this function doesn't recognize that, right? We have discussed initial value, scope, storage, address we have print, and lifetime. So all parameters of auto variables we have seen, right? So today we will stop here.